Hello, Debbie here. Let's look at the 5 transformations with the cosine function. All right, so a vertical stretch or shrink, we're changing the amplitude. So what I can see here is that my A value is 1/2. So the amplitude, remember, is the absolute value of whatever A is. So the amplitude of this function is 1/2. Normally for cosine, we would go up 1 to the max and down 1 to the min, but now the amplitude is 1/2, so we're going half the distance. We're shrinking the graph. Now, the difference between the graph of cosine and sine is, remember, cosine is at the maximum at the beginning of the cycle, so it's going to be up at 1/2. At the quarter, it's on the midline. At the midpoint, it's at the minimum, so it's going to be down at -1/2. At the 3/4, it's back on the midline, and it ends at the maximum. So here are the 5 points that we transform when we graph a new cosine function. So I can see now that my range is from -1/2 to +1/2. So I went up 1/2 and down 1/2 from my midline, which is the x-axis. Here we have y equals cosine of 1/2 x. Remember, 1/2 is b, and that tells me basically that that is actually a stretch. So this function y equals cosine 1/2 x will make half of its cycle will be between 0 and 2 pi. Okay, so what is the period? What's the distance that it does make one complete cycle? Well, remember, to come up with the period of our new transformed function, we take the period of cosine, which is 2 pi, and we divide by 1/2. So that's 2 pi times 2. We multiply by the reciprocal, which is 4 pi. So we can see it's been horizontally stretched. It now makes one cycle between 0 and 4 pi. So if I divide 4 pi into 4 equal parts, each section would be pi units. So here's 1 pi, 2 pi, 3 pi, and then 4 pi. So it's going to make one complete cycle between 0 and 4 pi. Amplitude is still 1. So highest points at 1, lowest points at -1. And then it stays the same shape. So we basically just start at the maximum at the beginning. At the quarter, we're at the midline. The midpoint, we're at the min. The 3/4 point, we're back at the midline. And at the end of the cycle, we're at the maximum. So here is the first cycle of the graph of y equals the cosine of 1/2 x. So we can see that if we look at between 0 and 2 pi, it's only made half of its cycle. So that's the correlation or the idea between the 1/2. Okay, so let's check out our other transformations. So how about a vertical shift? We know that changes the midline. Sometimes we will see that our constant, or what we call C, if you recall, is out front. So here, C is -1/2, which means my new midline is the line y equals -1/2. So it's the horizontal line at -1/2. So here is my new midline, which means any point that was on the x-axis is now going to be on that line. Okay, and from that line, that's where we go up to our maximum and down to our minimum based on the amplitude. This still has an amplitude of 1. So from there, I'm going to go up 1. So I'm going from -1/2, I'm going up 1, and then I'm going down 1. So the maximum or highest point is going to be at 1/2. And the minimum or lowest point would be at -1/2, or you could say 3/2. Sorry, I can't put that in there very good. All right, so we like to mark those so we know we don't go too far. All right, so at the beginning, cosine is at the max. At the quarter, we're on the midline. At the halfway, we're at the min. 3/4, we're on the midline. and at the end we're back at the max. So notice that I'm going up 1 from that midline at the beginning, the middle, and the end of the cycle. All right, and a horizontal shift, we said, remember, is a phase shift. So we talk about in here inside the parentheses if we're adding or subtracting something from x. Okay, let's look at a horizontal shift, a phase shift. So here we have x minus pi over 2, which is a shift to the right, pi over 2. That means then that instead of beginning at 0, we're going to begin at pi over 2, we're shifting to the right. So we're saying that's a phase shift of pi over 2, positive, or the first point in the cycle has an x coordinate of pi over 2. Okay, so what I like to do is I'm going to start there, and I'm going to say, okay, I know that the graph of cosine, my first point would be here, pi over 2, and it's up at the max. Now, where does the cycle end? Okay, well, remember it has a period of 2 pi because we haven't changed that. So I'm at pi over 2, and I have to add 2 pi to get to the end. Well, we know that 2 pi is 4 pi over 2. So 1 pi over 2 plus 4 pi over 2, or 1 plus 4 is 5 pi over 2. And since the period is still 2 pi, then we are going to divide that into 4 equal parts, and each part is 1/2 pi. So my cycle is going to end at 5 pi over 2, and remember it always ends back at the max. So I like to know the x values of my beginning and ending of my cycle, then I can come up with the quarter, the midpoint, and the 3/4. So here at the quarter, we're at pi, we're at the midline. Halfway would be 3 pi over 2, we're at the min. The 3/4, we're at the midline, and then we end back at the max. So here is the first cycle of cosine with a phase of this graph that has a phase shift of pi over 2. Okay, last transformation, reflecting about the x-axis. Okay, so we know the negative out front tells us that to reflect about the x-axis, which basically anything that's above goes below, anything that's below the x-axis goes above, any point on the x-axis stays in place. So we know cosine usually begins at the maximum at 1, but now if it's reflected, it's going to begin at the minimum. At the quarter, we're on the midline. Halfway, we're now going to be at the max versus the min. At the 3/4, we're on the midline. And at the end, at 2 pi, we will be at the min. So the max and min points switch, actually, if we reflect about the x-axis. All right, when the negative is on the x, that's a reflect about the y-axis. That is not fun with the trig graph. So what we do is we rewrite it based on the fact that cosine is an even function. And I know that if I put in the opposite x value into the function, I will get the same cosine value or y value, function value. That's what an even function is. The opposite x produces the same y value or function value. So that's telling me then that basically I can rewrite this function. I missed this function as y equals cosine of x, which means there is no reflecting, because if I reflect the graph of cosine about the y-axis, I have the exact same graph as cosine because it is even. So now I just graph it like it is. There is no reflection. And there's the 5 transformations on a cosine function.